friction or force of friction. This is a body. This is another body. This body either moves or tries to move. This is a body. This is another body on this body. When this body moves or about to move, then there is force here between two surfaces in contact in this direction. This force is called friction, simply friction or force of friction. When a body moves or tries to move on other body, there is force between two surfaces in contact. This force called force of friction or simply friction. It is denoted by F, capital F. Here surface is in contact. This is that force. This is force of friction. Cause of friction. Attraction between two bodies. Cause of friction. Every body attracts other body. This is what? Cause. This body tries to move, this body tries to stop its motion. Attraction. Second is interlocking of cavities. No surface is smooth. Every surface is like this. There are cavities in surfaces. This is body A, this is body B. No surface is smooth. Every is having cavities. When body moves, then interlocking of cavities this one is inserted in this one is inserted in this one inserted in this, and so on. So this is what cause. How to minimize friction. ये कोई we can't do anything because of these attraction, so only we can minimize this thing. अट्रैक्शन रहेगा, कुछ नहीं कर सकते हम यहाँ. सेकंड कॉज इंटरलेकिंग ऑफ कैविटीज. हियर वी कैन डू समथिंग. यूज ऑफ ऑयल और lubricants. Oil, lubricants filled in cavities. Size of cavities minimized. So friction minimized. Cavities, that lubricant is filled, so there is no interlocking or less interlocking. Change. Sliding friction into rolling friction. Then again what? Friction is minimized. We are pushing car. Imagine force applied. Now remove wheels, then push that car. Imagine the force. This means when there is rolling, the friction is less. Streamlining object, giving proper shape. Jet planes are pointed. Cars curved. ये ऐसी शेप नहीं होती कार की आगे से, ये कर्व. To minimize what? So this is what streamline. This is how to minimize friction. Friction is necessary evil. Friction is evil. there are two parts. It is evil but necessary. Because energy consumed more, wear and tear more. Fan friction है, it will consume more power, moreover there will be wear and tear, but necessary. As we cannot walk, talk, or do anything in life. This writing is possible, writing on board is possible because of friction. We can't do anything without friction. So this is what friction is, necessary evil. Friction is self-adjusting force. अपने आप एडजस्ट हो जाती है, किसी टाइम कम, सरफेसिस वही, किसी टाइम ज्यादा. When we start an object, then force of static friction goes on increasing until object start motion. This is time, this is force of friction, goes on increasing. Imagine I want to start a bicycle. I have to apply force. This force goes on increasing till cycle starts. Then it starts decreasing. And after some time, when cycle starts, the force of friction starts decreasing. After some time it is constant. So force of friction is self-adjusting force. वही टायर वही सरफेस जिस पर साइकिल चला रहे हैं हम, ये स्टार्ट यहाँ तक स्टैटिक फ्रिक्शन. दिस इज व्हाट? स्टैटिक फ्रिक्शन. फोर्स और लगाएंगे और जब साइकिल चलना शुरू करेगी तो फोर्स डिक्रीज होगी. आफ्टर सम टाइम इट इज कांस्टेंट. तो वही टायर वही फ्लोर, the force of friction is अपने आप, it is self adjusting. ज्यादा होती जा रही है, कम होगी, फिर क्या होगी? constant. When object start moving, force of friction decreases. And after some time, it becomes constant. So, friction is self adjusting force. इमेजिन करो कोई चीज चलानी है, एक कार ही पुश कर रहे हैं हम. वी हैव टू अप्लाई मोर फोर्स till car start moving. After some time, when car is in motion, that force decreases. When car still motion, then this force becomes constant. So it is self-adjusting force. Laws of static friction. Limiting friction. Static, no motion. This is an object, this is another object, this object about to move. Then this is the force. Where? Here, between two surfaces in contact. This is first law. Force of friction always acts in opposite direction in which object is about to move. Force of friction is independent on area of two surfaces in contact. Third, force फ्रिक्शन, कहाँ से ये? फ्रॉम आवर डेली एक्सपेरिमेंट्स. फोर्स ऑफ फ्रिक्शन depends on nature of two surfaces in contact. रबर बॉल कंक्रीट पर लुढ़काओ, सैंड में लुढ़काओ. From there, force of friction depends on nature of two substances. कंक्रीट वाली देर में रुकेगी. फोर्थ, this is weight of body. This is normal reaction. This is force of friction. This about to move. ज्यादा वेट है, ज्यादा फोर्स लगानी पड़ेगी इसको मूव करने के लिए. तो फोर्स ऑफ फ्रिक्शन किस पर डिपेंड करती? वेट पर. कितनी लगानी पड़ेगी? कम से कम इससे ज्यादा. ज्यादा वेट है, ज्यादा फोर्स अप्लाई करनी पड़ेगी. ज्यादा फोर्स अप्लाई करनी पड़ेगी मीन्स फोर्स ऑफ फ्रिक्शन मोर. दिस एंड दिस इक्वल एंड अपोजिट. तो the law is this directly proportional to this. Force of friction is directly proportional to normal reaction. That is F directly proportional to R. So this what? Force of friction is directly proportional to normal reaction. Force of friction किस पर डिपेंड करती? वेट. If more is the weight, more will be force of friction. Weight and ये क्या है? Normal reaction, equal and opposite. न्यूटन थर्ड लॉ, इक्वल एंड अपोजिट. जब ये सरफेस पर है तो सेम इज द वेट, सेम विल बी नॉर्मल रिएक्शन. लॉज ऑफ काइनेटिक फ्रिक्शन. Body, it moves. So this is force of friction. This is first law. Force of friction always acts in opposite direction. In which body moves. Second, third, fourth, as of static friction means second law independent on area, third depends on nature. Fourth, force of friction directly proportional to what? Normal reaction. Laws of rolling friction. This is ground. This is a body. This body rolls. So this is what? Force of friction. First law. Force of friction always acts in opposite direction in which body rolls. Second law, third law, fourth law, same. Fifth law, AR, radius of rolling body. Force of friction inversely proportional to radius of rolling body. This is force of friction inversely proportional to R, where what is R? R is this radius of rolling body. Coefficient of friction body, another body, motion, weight, normal reaction, force of friction. We know F directly proportional to R, laws of friction, where what is F? Force of friction. What is R? Normal reaction. This was fourth law. Whether static, whether kinetic friction, whether rolling friction. We know force of friction is this, or F. Proportionality, instead of proportionality, some constant. This mu is constant, called coefficient of friction, or mu F by R. This is definition of coefficient of friction. Ratio of F and R, force of friction and are normal reaction called what? Coefficient of friction. Units. No units. Dimensions. No dimensions. So this is what? Coefficient of friction. Angle of friction. Another question. One body, other body. This is what? Weight, always perpendicular to ground. This is say ground. Always normal reaction, always perpendicular to surfaces in contact. This is surfaces in contact. Perpendicular to surfaces in contact. इधर क्या है? Same motion. So this is what? Force of friction. This is a force. Normal reaction is force. This is force of friction. This is say their resultant. Two forces are there. One is force of friction, other is. So there is this resultant. This angle is angle of friction. Angle between R normal reaction and resultant. किसका है ये? रिजल्टेंट ऑफ force of friction and normal reaction. So this angle is called angle of friction. Between this and this, same thing I have written, angle between normal reaction R and resultant. To explain the resultant, resultant is of this called angle of friction. It is denoted by theta. Another question. relation between coefficient of friction, that is mu, and angle of friction, that is theta. Relation between mu and theta. This one, weight perpendicular to ground, normal reaction perpendicular to surfaces in contact. This is what force of friction, this is what motion, or about to move, whatever may be. This is resultant. And this is that angle theta. We know F mu r or mu F by r. Also, F by r, you take it parallel, F parallel, so F by r, F is perpendicular, r is base, tan theta. From first and second, mu tan theta. So this is what relation between F and R. Another question, angle of repose. This is inclined plane. This angle, when a body just not sliding, just about to slide, about to move down, just not, it is moving, about to move. This angle is what? Angle of repose. What? About to move. Angle of repose. Angle of inclined plane, where object is just about to slide down, called angle of repose. It is denoted by alpha. Relation between angle of friction theta and angle of repose that is alpha. This is the question. Relation between theta and alpha. This is angle of repose. Weight always perpendicular to ground. Normal reaction always perpendicular to surfaces in contact. This is surfaces in contact, this is normal reaction. So this will be what? Alpha. This will be what? mg cos alpha. This will be what? mg sin alpha. This is force of friction about to move down. From figure F, mg sin alpha. First, R, mg cos alpha. Second, therefore F by R, mg sin alpha, mg cos alpha, it is tan alpha. But look here, F by R tan theta, third, fourth, from third and fourth, tan theta, tan alpha, or theta is